We previously learned how to create a SAS dataset by directly inputting the data using the data line statement. This will get the job done, but it's not very practical, particularly when you have larger datasets. Additionally, as a SAS programmer, you will usually be given data that is already stored in a file of some sort. For our purposes, any file containing data that is not a SAS dataset is referred to as raw data. In my experience, raw data is commonly shared in a file that ends in .csv, or comma-separated values, or that ends in .xls, a Microsoft Excel file. But remember, generally speaking, SAS can only manipulate, analyze, and present data that is stored in a SAS dataset. In this lesson, you'll learn how to take data stored in several different common types of files and put them into a form that SAS can use. There are many different file types that one can use to store data. In this lecture, we'll focus on data stored in text files, CSV files, and Microsoft Excel spreadsheets, as well as other SAS datasets. By default, SAS assumes that the values are separated by a single space. Not necessarily because this is the most common format you'll encounter. In my experience, it's not. I guess the good people at SAS just had to pick something as the default, and a single space was it. At the end of the day, why this is the default really doesn't matter. All that matters is that it is the default. So that's the file format we'll use to start our discussion of reading in raw data. When you read in data from a text file with values delimited by a single space, you use the input statement to tell SAS what variables to put in the dataset, just like you did with the in-stream data in the previous modules. The input statement shown here uses a list input specification for standard data. List input is one of three specifications you can use in the input statement. List input can describe standard or non-standard data, and delimiters must be used to separate the values. So what's the difference between standard and non-standard data? Standard data is data that SAS recognizes automatically, without any special instructions from you. Non-standard data includes values like dates, or numeric values that include special characters like $signs. SAS needs extra instructions from you to read non-standard data. You'll learn more about non-standard data later. For now, we'll just deal with list input for standard data. Imagine for a moment that this is your raw data file. There are 3 observations in this data, 1 per line, and each observation contains 5 variables: participant ID, first name, last name, sex, and a dichotomous variable representing some disease condition that takes on the values 0 or 1. At the top, in blue, is a ruler of sorts that helps you visualize what column each character is in. However, in a real raw data file, the blue ruler would not exist. When your raw data is delimited, then values are all separated by the same character, or, as is shown in this example, by a space. Another commonly used delimiter is a single comma, as shown here. But you could also use a period or some other character. The important thing is that all the values are delimited in the exact same way. With list input, it makes no difference what column a variable starts or ends in. SAS just begins reading from left to right and jumps to the next variable as soon as it encounters a delimiter. Later, we'll discuss options for handling data that does not conform well to the rules for delimited data. If your raw data file is arranged in columns rather than being delimited, you can use either column input or formatted input. Column input is standard data arranged in columns. Formatted input is standard or non-standard data arranged in columns. This is an example of raw data arranged in columns. Notice that now there is no consistency in the number of spaces between values, but the values for each variable all start in the same column. Here's the input statement again. You specify the variables in the order that they appear in the raw data file, from left to right. You specify a $sign behind any variable you want to create as a character variable. By default, SAS creates each variable that you list with a length of 8 bytes, regardless of whether it's a character or a numeric variable. If the data step doesn't contain any other statements that create variables, SAS stores variables in the new dataset in the same order and case that you specify in the input statement. For our first example, we'll read in a text file with values separated by a single space. The contents of the file are the now familiar height and weight data. Here you are telling SAS that you want to create a new dataset called HT_WT1. And because you didn't specify a libref before the file name, SAS will create this dataset in the work library by default. Next is the infile statement. The infile statement tells SAS where to go find the raw data you want to build this SAS dataset out of. Think about it. You are telling SAS to go get data in this file. It makes sense. Then you have the input statement, which should be familiar to you by now. You are telling SAS you want to put variables in our dataset named ID, sex, HT_IN, WT_LBS, and BMI_cat. Finally, you will end this data step with a run statement. Let's submit it and see what happens. The log says that you have invalid data for the variable HT_IN in line 1, columns 8 through 12. Let's look at the data and try to figure out what the problem might be. Look at row 1. That's the problem. The variable names were stored in the text file, which is not uncommon, but SAS isn't smart enough to know that on its own. So you have two options here. Either delete the first line from the raw data, and I recommend that you never alter your raw data, or you can tell SAS to read the data beginning on the second line of the text file. Let's try doing that now by adding the first OBS option to the infile statement. Here you are telling SAS that the first observation that contains data is in row 2. Now, let's submit your program again. It looks pretty good, but notice that the values for BMI_cat seem to be truncated. You'll see how this truncation happened and how to avoid it later in this session. I want to quickly point out something else for you to be aware of. Here is the text file single2. What is the difference between single and single2? Whoever entered this data accidentally skipped over the height for participant number 2. Let's replace single with single2 in your program, run it, and see what happens. SAS still ran, but this time you get an error message. Let's look at the dataset in the View Table window. Notice that the dataset has errors. It's because SAS isn't smart enough to recognize height is missing for participant 2 and fill that cell with a period. Instead, it fills it with the next number it encounters. The only way to fix this error is go back to the raw data file and place a period where height should have been. That's exactly what was done in the text file titled single3. See how SAS handles the data when you replace single2 with single3 in your infile statement. Now there's a period in HT_IN for observation 2. The period represents a missing value for a numeric variable in SAS datasets.